11. How are you? I hope you are fine and healthy. Today we will cover the static problem in math apps. So let's get started. Question number 1. The mass of a body 6 kilogram. If the body is placed on a rough inclined plane that makes an angle of measure 30 degree with the horizontal, and the coefficient of static friction between the body and the plane is root 3 over 3, then the body what? Firstly, if the body is placed on a rough inclined plane that makes an angle of measure 30, so theta equal 30 degree, and the coefficient of friction between the body and the plane is root 3 over 3. That means that mu equal root 3 over 3. Mu equal tan lambda, so tan lambda equal root 3 over 3. So shift tan root 3 over 3, so lambda equal 30. Here, if theta equal 30 and lambda equal 30. Since the theta equal lambda, so the body is about to move down. The body is about to move down. Okay, the body is about to move down the plane. Second, is the magnitude of limiting friction 60 Newton and the coefficient of friction is 0.75, then the magnitude of resultant reaction. Okay. I have the magnitude of limiting friction 60, so Fs equals 60, and the coefficient of friction, mu equal 0.75. he need the magnitude of resultant reaction, he need R. Okay, R equal root Fs power 2 plus n power 2. Okay, and Fs equal mu times n. Fs equal 60, mu equal 0.75 times n. Here over 0.75 and here over 0.75, so n equal 60 over 0.75, it will be equal 80. So n equal 80 and Fs equal 60, we can get the R. R equal root Fs power 2, so equal 60 power 2, plus n power 2 equal 80 power 2. Root 60 power 2 plus 80 power 2 equal 100, so R equal 100. Number 6. A body of weight 20 Newton is placed on a rough horizontal plane. If the coefficient of static friction between the body and the plane 4 over 5, then the force which makes the body about to move. Since the body it will be about to move, I have the coefficient of static friction 4 over 5. I have mu equal 4 over 5. And we will know that F equal f of s in case of the body is about to move. Okay? And f of s equal mu times n. Mu equal 4 over 5 times n. N هي normal reaction. In case of the body is about to move, so it's the weight of the body. If here equal 20, so the normal reaction also equal 20, so n equal 20. Okay, so it will be 4 over 5 times 20 equals 16. If the static friction equals 16, so the force equal also 16, so F equals 16. Last question. A body of weight 65 Newton is placed on a rough inclined plane, makes an angle with horizontal cosine 12 over 13. A force acts on it upward along the line of greatest stop. If the coefficient of static friction is 2 over 5, find the limits of the magnitude of the force that keeps the body is in equilibrium on the plane. Firstly, if the body is about to move, if the body is about to slide down, if the body is about to slide down. So we can draw the body. Here the inclined plane, and here the body. His weight is 65, and this is normal reaction in, and we can resolve the weight. Here 65 sin theta, cosine theta, and here 65 sin theta. Okay, and here theta, and here the force that he need. As the body is about to slide down, so f of s here, f of s here. Okay, since the body is about to slide down, so f plus f of s the two forces equal this force. F plus f of s, f plus f of s equal 65 sin theta. I have theta, I have sin theta equal 12 over 13, so we can draw the triangle. Here theta, sin theta 12, opposite 12 over hypotenuse 13, so from Pythagoras it will be 5. So I need f, we can move f of s to the other side, so f equal 65 sin theta minus f of s. F of s means mu times n. Okay, so 65 times sin theta, it will be 12 over 13 minus mu equal 2 over 5 from the question, 2 over 5 times n here equal 65. Look at the draw, 65 cosine theta, so it will be 65 cosine theta, cosine theta. But I have cosine theta equal 5 over 13 adjacent over hypotenuse, so we can write here 5 over 13, 5 over 13. By using calculator, 65 times 12 over 13 minus 2 over 5 times 65 times 5 over 13, it will be 50 Newton. Okay, so F in the first case equal 50 Newton. In the second case, if the body is about to move up, so we can draw the inclined plane, and here is the body, and its weight 65, and here 65 sin theta, and here 65 cosine theta, and here theta, and here the f, and here the normal reaction n. If the body is about to move up, so the fs will be down, so f equal fs plus 65 sin theta. I have theta also, because theta sin theta equal 12 or 13 from this triangle. Okay, okay. Fs equal mu times n plus 65 times sin theta equal 12 over 13 opposite over hypotenuse. Mu equal 2 over 5. Mu it will be equal 2 over 5, so 2 over 5 times n equal 65 cosine theta equal 5 over 13 plus 65 times 12 over 13. By using calculator it will be 70, so F equals 70. So the force that he needs, it will be belong to 50 and 70 in the enclosed interval. And thanks for listening.